Hi, I hope you're doing awesome. So the question we are seeing today is star of Hanoi problem. So it's one of the problems that build the foundation of recursion, that why exactly do recursion works, like, and if you are a newbie, it's fairly hard to understand the problem. So I want you to be 100% attentive and focused so that you can grasp the problem. Otherwise, it's fairly tough for a newbie, right? Also, to understand not the code actually, that why is the code actually working is a tough job. So let's get started. Let me explain what the problem is. Right. So we are given a board which has got these three towers, right? And there are suppose three plates here. One plate, and three plate. Third plate, right? So my goal or my objective, let's call these stars A, B, and C. My goal is to move all these three plates to tower B, from tower A to tower B, using C as an intermediate station or an intermediate tower, right? So there are some rules for the game. The rules is firstly, only one plate will move at a time, only one plate at a time. Also, you cannot place bigger plate over smaller one, right? You cannot place a bigger plate on a smaller plate. And once again, the goal is to move all the plates from tower A to tower B using tower C as an intermediate point. You cannot place a smaller plate on a bigger plate, and you can only move one plate at a time, right? So I think the question is fairly clear at this moment, right? So let's see, if we were to do it manually or by hand, what would have it done, right? Okay, so just a second. Yeah. So I can say that I would have taken my plate A, placed it to B here. Then I would have taken my plate 2 and placed it to C, right? A little bigger than the first one. Then I would have taken my plate 1 and placed it to C, the tower C, right? Here. Then I'll take my plate, the biggest plate, right? Plate 3, and place it to tower B, right? Now I'll take my plate 1 and place it to tower A. I'll take my plate 2, just a second. Plate 2, we'll place it at tower B. As you may see that it's really complicated to do that, right? And it's just three plates as of this moment. What about five plates or 10 plates? It's gonna be tough, right? And then the last plate, which is the plate 1, smallest plate, and we'll place it here. And we have shifted all the plates from tower A to tower B with the help of tower C, and we didn't violate any rule, right? We never moved more than one plate at a time. We never placed a bigger plate over a smaller plate. So we did this following the rules. Now my task is to write a function which will eventually print all the instructions, right? Instructions to move all the plates from source tar to destination tar using auxiliary tar, yeah, using auxiliary tar. So this is what I have to do. I need to write a function which will print all the instruction following which my goal will be achieved, right? So I think the agenda of the video is clear. Okay. Now, how do we actually do that? I want you to have faith in what I say as of this moment, even if you don't understand it, because if you proceed with the video, you'll fairly be cleared about the topic, right? Okay. Firstly, let's draw that board again. Suppose there were n number of plates here, right? This is my source star, this is my destination star, and this is my auxiliary star. Okay, suppose there are n number of plates, right? Have a faith in my function that it knows how to move n minus 1 plate to auxiliary tower with, of course, following the rules, right? It always follow the rules, never violates them. So now I'll have only one plate left in source star and n minus one plate in auxiliary star, right? Now what I'll do, my working is place the last plate, that is the nth plate, to destination from source, right? I'll place this last plate to destination using using actually there is no use of auxiliary tower, right? I just have one plate, so I'll just place it here from source star to destination tower. Now I'll again have a faith that as my program placed all the plates from, actually not all the plates, n minus 1 plates from source star to auxiliary tower, it now knows that how to actually place them back to destination tower using source star as an auxiliary or intermediate tower, right? So now I'll have a faith that my program will place n minus 1 plates to destination tower using source star as an intermediate station or whatever you call it. So now I'll plate n minus 1 plates from auxiliary tower to destination tower using source star as intermediate. And if I am able to achieve it, that is, I also plate n minus 1 plates, I also place them, then I have eventually placed all the n plates from source star to destination tower using auxiliary tower as an intermediate, right? Now let's try to code it and then I'll dry run the code that why is it actually working, right? So let's see the input format. I need to take a number n for the disks. So int n is equals to scn dot next int, and we haven't made the scanner object, right? So let's just make it scanner scn is equals to new scanner system dot in. So we have the number of plates and x is equals to, or we can do this. So this one is star 1, this is star 2, this is 3, right? So we have taken the tar ID and we have also taken the number of disks we need to move. Now I'll just call my function, that is tar of Hanoi, and source star, that is T1, the destination tar, that is T2, and sorry, it should be T2, and the final, the auxiliary tar, that is T3, right? Now let's do the first faith call. That is, my program, the tar of Hanoi program, knows how to move n minus 1 disks from tar 1 to tar 3, it's T1 ID, to tar 3, that is the auxiliary one, using it should be T3 ID, right? The auxiliary one is T3, using T2 ID as an intermediate station. Now all I have is to place one disk, that is system.out.println. Let me code it in full screen. I must be obstructing the view, right? Firstly, I'll print n because it is the nth plate. And then, yeah. Then the source ID, that is T1 ID, plus this arrow thing we need to place here. That's the output format, right? I know it. You can see it. To T2 ID. And we close the graph. I hope this is the output format. Now, I'll make the second faith call. That my tar of Hanoi program can now place n minus 1 plates from the auxiliary tar, that is T3 ID, to the destination tar, that is T2 ID, using the first tar that was originally the source tar, but it will now be used as an intermediate station, T1 ID. Right. Also, if I ever encounter a scenario where there is no plate, right, that will be our base case. So if n is less than or equal to 0, if we have no plate, then we just have to returned, right? We just returned from there. I think it should work. Let's try to submit it. So it's getting accepted. Let's try to submit it now. Okay, so it's getting submitted, but you must be having some doubts. So I'll dry run the program for you. Show this down. I'll dry run it for 3 disks maybe. Erase anything. Right. Let's say that there are 3 disks. Here. 3 tars. Let's call them A, B, and C. And there are 3 disks. Or maybe let's draw the T diagram. That will be far more appropriate than this, right? Okay. So firstly, let's call there are 3 disks, and let's call the tars to be A, B, and C. Okay. It will have 2 calls. The first one will be for n-1, that is 2, T1 ID, that is A, and we'll swap the last ones, that is B and C, so it will be A, C, and B, right? And the second call will be, for, or maybe, yeah, the second call will be for n-1, that is 2, T3 ID, that is C, and then T2 ID and T1 ID, that is B and A, right? Now it will again have 2 calls. It will be 1, and then A, B, C again. I hope I'm doing it right. So for the A, T3 ID is B, and yeah, okay. And the second one will be 1, T3 ID, that is B, T2 ID, that is C, and the T3 ID is A. Okay, and it will also have 2 calls. Just bear with me. It's actually a slow process, but you'll fairly be clear about the question after I dry run the program, right? So just bear with me. Right. Thank you very much. So for 1 and 1, we write C, A, B, and T3 ID, that is A, T2 ID, that is B, C, right? And then there will be call for 0, which will eventually result in nothing, right? Because if it's equal to 0, we return, right? So let's see how it actually works. So everything is being done in order, right? Because the first call, the second call, and we are doing the working in order. So let's see, when our recursion moves here and it falls. Now here is the in order. So what do we write is n, that is 1, T1 ID, that is A, to B, to T2 ID, that is B, right? Okay. So maybe just shift the output there. Okay, just a second, please. Just a second. Yeah. Now we again move up. Now we again move up, and it's 0. So we'll fall down and we'll hit the in order of this, right? So it will be n, that is 2, A. Okay, so we write A to C. Okay, after that we again move up and we hit in order of this, that is 1 from B to C. Then we move up and we fall in order of this, right? That is 3, the third plate, from tar A to tar B. Okay, then we move up. Then we fall in order of this, that is first plate from C to A. Then we go here, that is second plate from C to B, right? Then we move up, we hit the in order of this, that is the first plate from A to B, right? These are the instructions printed, and I hope there is no other call because this is all post order, right? Now let's see if we are actually doing the working using these instructions. So are we really printing, or are we really shifting all the plates from tower 1 to tower 3 using tower 1 to tower 2 using tower 3? Let's see if it actually works or it does not, right? So we have these plates here. Okay, so it says that the first plate moves from A to B, right? And also just name the tower. This is A, this is B, this is C. The first plate moves from A to B. Okay. The second plate moves from A to C. The second plate moves from A to C. Right. Just a second. Now, the first plate moves from B to C. The first plate moves from B to C. It's important to confirm that if our code works, right? Because that actually helps us to build the understanding that why is it actually happening what we have written, right? So let's see. After that, the first has moved to C. Now the third needs to move from A to B. So we'll take the third plate. We'll move it from A to B. Right. Third is moved. Now first from C to A. The first one from C to A. Right. Now okay, just a second. It is done. Second from C to B. Second plate. This from C to B. And then after that, first plate from A to B. Right. So following all these instructions, our task is done, that we have moved all the plates from A to the tower B using C as the intermediate station. And the main thing is following the rules, right? We never broke a rule. So I hope you liked the explanation. And if there is any part which you didn't understand, so I actually urge you to watch this video again, rewind it, and maybe watch it 3 times perhaps, because this is really foundation question of recursion, right? So it's important for you to understand it clearly. So I hope you liked the video. Kindly subscribe to the channel. Thank you very much.